If you are here today, make sure you email me sometime in the next 24 hours to be excused from the next homework assignment. You will have a 100 out of 100. For those of you who are not here, hi. If you are taking this class remotely, you're on the honor system, but you actually are watching this lecture because I will not be posting this homework assignment. I will not be telling people about this homework assignment. You are responsible for watching the video and seeing what you missed. You are not allowed to tell anyone in the class that they have a homework assignment. So if you want the homework assignment, you need to email me. If anyone tells anyone in the class about the homework assignment, you will be violating the honor code. And you will have a 1,000-point homework assignment that will be quite challenging. Okay, so for today what I want to do is I want to talk about a couple of different things. So the real question, wait, it's supposed to be on pause so it's not moving. So what I want to do is I want to talk about a couple of different things. I want to talk about how we would look at problems and how we would possibly attack them. So for instance, early in the semester, we had a distinguished visitor, Professor Sue, who gave us a talk on rental harmony. We have the tools to divide up rental costs. The question is, how do we use Sperner's lemma? And so I don't want to actually solve it right now. I want to just talk a little bit about how you might try to use it, what you might be thinking about. So let's imagine we have 3 people and we want to split the rent for an apartment. You can start making what you will consider reasonable assumptions. For enough money, any person will take any vote. How much do you want to have the total rent be? $300. Okay, well, $300 is a natural answer. What else is a natural answer? $1. $1. What's another natural answer? Let's say $3 would be another natural answer. You know, 300 is like $100 for each. You know, there's a lot of ways around this that you can do. So, any preference?
I like mine.
You like those answers? So your answer was $300? So we have $300 in rent. And we have 3 different rooms. So each person has to get a room. Each person is going to have a different preference of how much they like the room. How can you make up for the fact that somebody might be getting a room that's not as good? Yeah, exactly. Right? How much rent do you pay? So if all the rooms were equal, how much should each person pay? $100. So what you could do is you could assume that they've already put in a certain amount of money, and then we have to allocate the money back. Money is nice because for the most part it's continuous. Who is familiar with the story of Solomon and the child? Anybody want to briefly relate the story of Solomon? Yes.
So there's 2 women who come to Solomon with a baby.
Right.
And they're both claiming to be the child's mother. And Solomon says, they say, Solomon, we need you to determine which of us is the mother. And so Solomon says, all right, I have a simple solution. We'll cut the baby in half. You'll each get half a baby, and you'll both be happy.
Now the problem was he wasn't cutting it down vertically, he was cutting it down horizontally. And the two,
it
doesn't matter how you cut the baby.
And then one of the women immediately is like, no, give it to the other one. And he says, you're the mother.
Right.
And that's the whole story.
Yes. So there are certain objects that you really cannot divide. You can't give somebody half a baby. So money is nice because we can move it freely from person to person. How much money should each person initially put in? Yeah, I think there's 2 different ways to look at it. So again, I don't particularly care about the answer because I'm not in a situation where I'm going to be renting. So each person should initially put in $100. That's one possibility. So you have people getting A, B, and C, and each initially put in $100. What is the problem if they each initially put in $100?
Well, if you're going to kind of do reallocation, someone might have to put in additional money later on that's not in the problem right now.
Right. So imagine we have to reallocate, and I will be in the SOB. You say that I got the best room, and I have to put in an extra 50 bucks. Oh no, I got the worst room. And so if you do something that way, they each put in $100, you have nothing left over, and you've got to make sure you have the $300 for the landlord. So how much did each person put in initially? 300. Okay. So I strongly, strongly, strongly urge you to watch the beginning of today's video and then email me. Do not talk to anyone else in the class about what happened. I just urge you to watch the video.
Okay.
And do not talk to anybody else in the class until you watch the video.
The video first.
The video for today. So how much are we going to put in now, each person?
300.
Yes, if each person puts in $300, then you know you're going to have enough money for the rent and enough money to reallocate. So now you have, $300 goes to rent, and you have, how much to get back? $600 to reallocate. What lemma do you think might be helpful for this? Spoon's lemma, right? I've got a triangle drawn. I mean, I could label them instead of A, B, and C. I could label them 0, 1, and 2. If I really want to drive home the point. So the question is, how would Spurner's labeling help us? What is the actual problem we would want to apply it to? Is it clear how to use it? Professor Sue did talk about this, so you've seen it. Spurner's lemma tells us that if we have some kind of labeling, 0, 1, 2, 0, 1 down here, 1, 2 down here, 0, 2 down here. I don't know. So we have some kind of labeling like this. There will be a 0, 1, 2 triangle. How does that help us? So it's not always clear how to use a mathematical theorem. We've seen already that this is supposed to be useful. What do you want the 0, 1, and 2 to represent?
You might somehow label the vertices with different rent allocations and then have each person kind of select the vertices that they're okay with or something.
So
along those lines.
what could this vertex represent?
Give all the reallocation to 0.
Yeah, give all the reallocation to 0. Do you think 0 will support this plan?
Yes.
0 is actually a really good soul and believes in fairness and equity. No, 0 will support this. And then if 0 wants, 0 will then reallocate the money as 0 sees fit. But 0 is not going to object to getting all the money back and then doing with what they wish. So this would be giving 100% back to 0. This would be giving 100% back to 1. This would be giving 100% back to 2. It makes sense. Along this line, who are the only people who get money back? 0 and 1. So it makes sense that 0 and 1 will always support this down here, and then this will be labeled 0 and 1. So this looks like a promising start. It's beginning to meet all the requirements we need, and then as we go inside, then we start actually allocating the money among the different people. Do you think that this will lead to a solution? So let's say, which room is 0 getting? Is their room changing? Or are we always giving 0, 1 room, 1, 1 room, and 2, 1 room? We have 3 rooms and 3 people.
Maybe we're in some way allocating which position in the pick order you get or something like that.
Okay, so maybe it could be pick order. And we saw some interesting discussions in the last class about what happens, how much different pick orders are worth. So the people may assign different values to rooms. When I was in grad school, we had some rooms that were large and some rooms that had a fireplace. And for a while, it was legal to have a fire in your fireplace in graduate school. It was not legal to have a halogen lamp on. And so, being the inquisitive young scholar that I was, I of course contacted the fire marshal and said, if I carefully plug in my halogen lamp in the fireplace and run an extension cord, am I allowed to turn on the halogen lamp? You can imagine the response I got. So, but you have different things that you will value. Some people will value the fireplace highly. When you're buying a house, what do you think is the most important thing of a house?
Location.
A lot of people, it's location. And what does location mean? Is it close to work? Is it close to a good school? Is it close to a city? Other people will value space. And so depending on what you value, different people will value the different rooms in different ways. So I need to know if we're going to go forward with this. Are we just saying, look, let's make it simple. Person 0 gets room 0, person 1 gets room 1, person 2 gets room 2. That's always going to be the case. And if we do that, we are then just going to allocate the money. So you get room 0, you get room 1, you get room 2. You're stuck with that, and then we just have to decide how much money to give each of you to compensate. Do we like that, or do we want to have the rooms varying as well?
If people have different preferences, it might be beneficial to have the rooms vary.
So in terms of beneficial to society, to bringing happiness, absolutely you want to take into account who gets which rooms, right? Imagine I've given you your least favorite room, and you could all switch orderings and you would all be happy, right? But is it easier to analyze if we just say, you get room 0, you get room 1, you get room 2, and then let's just reallocate the money? Yes?
Might there be some way to do this for every room allocation and then vote for something to pick amongst the room allocations?
There's many things you can do. So today the whole point is to talk about how to attack a problem, not the solution. The solution is just a few lines. And we've actually seen those few lines. I care more about the thought process as to how would you attack something with the hint that we know what to do somehow. But I often like to do the simplest case first. Does it work? And then see if by doing more work we can get something better. So can we at least get a solution that the three of you will agree on if we just reallocate the money? Do you think that that will be possible? And before we do the analysis, you get room 0, room 1, room 2, and then we'll just resplit the money. Or do you think it might not be possible? What do you think? Should there be a way of reallocating the $600 so that all three of you are willing to accept it?
I think if we're having to pick vertices, no, because everyone's incentivized to pick none of them.
Well, I mean, you would...
Because if you're 0 and you pick none of them, then you get $600.
Right, but you need people to agree to that. So, I mean, you would definitely accept something here. We want to color each vertex 0, 1, or 2.
Remembering Professor Sue's talk, there was one question of does every person think that they got something that's equal to everyone else, versus does everyone think that they got something that is at least 1/3 of the cake,
yes.
so to speak?
So
those are different
there are
questions.
two very subtle differences. A lot of times, especially sadly in divorce, people aren't concerned with getting a certain amount. They're more concerned with causing pain and suffering. And so there's this whole notion of envy, that if you are allocating things, you don't want to feel like you were screwed. But do we think that there will be a way to allocate the money so that the three of you will be happy? Let's start off over here. So, Will, if I give you 100% of the money, are you fine?
Yes.
99%.
No.
You are that. Fine. Will, you're out. Clay, you're in. Clay, you're now person 0. You have been discarded as an unreasonable data point. 99%, are you happy with that?
Of course.
Yeah, I mean, thank you. A little bit more just shocked, but 98%.
Yeah.
Let's go a little bit past 90%.
Yeah.
60%.
There's 3 of us?
There's 3 of you.
Yeah.
Yeah. 50%.
Okay.
A third.
Patents.
Okay, what does it depend on?
My room. Probably.
I mean, I don't understand why people prefer to have the beds horizontal and not vertical. It's much more efficient to have the bed vertical. No. So, one of the rooms could be truly horrible and so much worse that you would not accept a third. So, again, it could start to depending on your room. 10%.
Room better be.
Yeah, I was going to say, the other two rooms are the ones that have the vertical bed like this. And you have almost everything. You've got a fireplace, the double-decker couch from the Lego movie. It's awesome. So there's definitely going to be some critical threshold for you where you'll say no. And the threshold could depend on how you value things. So what would that look like geometrically on this? So let's say your threshold was 50%. What would that look like? What part of the triangle would you prefer? Would be willing to accept?
It's going to be on the bottom left portion.
Okay, in what
If
way?
you're 0.
Like this? Straight up?
A line kind of diagonally, because you don't actually care.
So
how
what's the
much money
slope?
went
What's
into
the slope of the line?
it. Ooh, what's that? -3? -2?
Well, you can just tell me by looking at this picture, what is the slope of the line the same as?
2.
This one over here. So you would have some threshold, maybe it's over here, where you'll accept anything in that region as acceptable. You want to get at least this percent if you're getting room 0. And then anything in here, you're getting that percent back. The difference is how much is allocated to person 1 versus person 2. And now you can begin to see the problem. What about person 1? They're going to have a similar line. In order for there to be a solution, that line has to go at least as far as this, preferably higher, so that they all intersect. We'll assume, person 1 is, really sure, I don't give a shit. I'll take anything in this range here. And then person 2 has the little closet that has the vertical mattress. And person 2 is like, if you want me to take this, I need almost all of the money. And person 2 would basically just say something like that. Beyond 85, 90% of the money, it's not worth it to me. So I love extreme examples. This is enough of an example where we can do this very easily, and we can see that if we don't take into account the preferences and the values people have for the rooms, there is not guaranteed to be a solution. Then how do you solve this? Then that's the paper, the rental harmony paper. And I'll leave that for you to read, and for your classmates to read and do some problems on. But whenever possible, try to do extreme cases. And so I'm hoping that this was somewhat of a surprise, because when I was mentioning before we did this, should we be able to find a solution? It felt like the consensus of the class was either I don't know, or there should be a solution possible. Is if everybody just chooses their room and has it fixed, if we give people enough money. The problem is there's not necessarily enough money for everybody. And that's the problem. Okay, any other questions on this? So this leads nicely into the category of divorce. So there are a couple of lectures that I hope you never use in life. This is one of them. The other one, and in fact, it's funny, I actually just had breakfast with a former student of mine. He's getting his PhD right now, and he's coming here for the day. Economics student, math double major. He gave a wonderful colloquium talk on the marriage problem on Valentine's Day many years ago. It was perfectly timed. He did it very well. I do have one student who is still single, who is trying to use the marriage problem to find a partner, where you look at people one at a time, you sample the first so many, and then you take the first person better than the best that you've seen. Now, the problem is complicated a little bit by the fact that you don't necessarily know how many candidates you have available. But even if you assume you know how many candidates there are, it's an interesting question. So imagine you are married and then there's going to be a divorce and you have to split the assets. So we talked a little bit about Solomon dividing the baby in half. There are certain assets that cannot be or should not be, I guess you can divide the baby, but you should not be dividing certain assets in half. So give me some possible assets. House. Now, I don't know if you've played it, but I did send you, I think, the link to the movie War of the Roses. Did I send you this? So Danny DeVito plays the lawyer of the husband in a pair that's splitting up. I think Kathleen Turner is the wife. I think Michael Douglas is the husband. And neither one of them will give up the house to the other. They can't bear the other one to get it. So they actually split the house in half. And different people get different parts of different rooms. And he's explaining this to his lawyer, and his lawyer's just looking at him in shock. He goes, I can't believe this. This is absurd. No, look, I got more square feet. It's not about who gets more square feet. You do not want to be living in a house in this situation. So house cannot be split up easily. What else? Car. When my brother and I were young, we were dividing up the family assets. And at one point we got 2 parents. Because you actually can split them up. There's 2 of them. And so it was like, well, okay, if you get first pick of parents, and I get first pick of house and car. And I still remember one of my parents, I think it was my mother, asked me, what if we want to stay together? And my brother and I discussed this, and no, neither one of us is willing to take both of you.
So if there's an odd number of kids?
So if there's an odd number of kids, if there's an even number of kids, it's easier.
Or if there's an odd number of good kids.
Yes. But it could be interesting, you get first pick of kid, and so okay, house, car, what else might be hard to split up? Children. Oh, I see, sorry, I didn't realize, yes, children. What else?
Family, pets?
Pets. And actually, some pets you actually have to explicitly leave instructions as to how they will be cared for in a will. I think parents, you have to do that. Anything else? Furniture. So there's a lot of items you can add to the list. What's easy to split? Money. And so this is one of the reasons why we love money so much. Now, you might have a dispute as to how the money should be split. Imagine the only asset is money. How should the money be split? So it seems reasonable to say that as a default, if all you have is money, the money should be split 50-50. And can either person then argue that the other one got more? No. Now, what you could argue is maybe people didn't contribute equally to creating the money for the family. And then it gets really complicated. So there are a lot of situations where one parent actually works jobs while the other one goes to school or advances their career and one stays home. And then it becomes very complicated. And that's why it's often just split 50-50. So how should we split things like house, car, children, pets, stuff like that?
This doesn't work so well with children, but you could try to liquidate most of them.
Yeah, okay. I am very glad that you're not advocating liquidating children.
Auction.
Okay, so what we could liquidate. Now, like non-kids, just to be absolutely clear what is being advocated. Auction. And again, there was a wonderful Twilight Zone episode years ago where basically parents are in like zoo cells and little kids walk through and try to decide who they want to be their parent. And I still remember, I baked the most delicious chocolate chip cookies. So we could liquidate, we could auction. What else could we do? Okay, if these are only 2 options, then we'll do one or the other. We could do a mix. What is the problem with liquidating or auctioning?
You don't get to keep the stuff.
I'm sorry?
You don't get to
So
keep
no
the
one
stuff.
gets, well, you might not get to keep. How would you be able to keep something in a liquidation or an auction?
By bidding on it.
By bidding on it.
Yeah, so if you auction, you might not have enough liquid assets for one to buy the other out in a fair way.
Mm-hmm. So there's going to be issues with this. But there's another problem with liquidation or auctioning. And this is actually somewhat responsible for the housing crunch that led to the Great Recession around 2008, 2009. So a lot of times when you're getting a mortgage, you get a different rate depending on how much you're asking for, as well as how much you're putting down. The more you put down, often the better rate you can get. Why?
Because if you can scrape together $200,000, you're probably going to be able to pay off your mortgage.
So one is that if you're putting down more money, but I didn't say the amount you were putting down, I said the percent. So if you put down more money, okay, but why do you think banks feel more comfortable with a mortgage if you're putting down a greater percentage? You have a great equity, so why does the bank care about the equity you have? I mean, are they concerned about my well-being?
If you default on the mortgage, they get the house.
So you default, okay.
We're more likely to like stay with the house than walk away.
So you're more likely to stay with the house than walk away if you have equity in it. So if you have to put 20% down, it's if you just declare, oh, I'm bankrupt, okay, that's fine. You've now lost 20%, and that's a significant amount. If you put nothing down, then there's no incentive to prevent you from declaring bankruptcy. But there's another reason. What is the bank going to do, say, if you declare bankruptcy and they own the house now?
They're going to resell it.
They're going to resell it. And what do you think happens when the bank resells? So how much do we want the house to cost? Let's give me a nice number. $1 million. You know, $1 million, $100,000, $1, all of those would be acceptable. So let's say the house costs $1 million. How long does the bank want to hold on to that house before they sell it? Because the longer they hold on to it, the more they're losing in some sense. So the bank may not be able to sell the house for $1 million. Now think back to my question as to why do they care about the percent you put down? Why does that matter?
Because they actually get that money right then.
So the
If you put, it's just like the threshold.
the amount that you put down, if you put down 20%, that goes to the person who owned the house before.
Oh, okay.
And you have a loan from the bank for 80%.
It's just the threshold that the bank has to clear when reselling.
Yes, it's the threshold the bank has to clear when reselling. So let's say the house is worth $1 million. You put down 20%. The bank is able to sell it for 90% of its value. The bank still makes money. You put down 0%, and the bank is able to sell it for only 90%. Now the bank has lost a tremendous amount of money. This was the problem with a lot of these, zero down loans. And a lot of stuff like this was built on some very bad studies, I think in the Federal Reserve, where people misinterpreted some data in terms of the probability of people being able to pay back loans and mortgages. So when people have 0% down, as the bank starts to accumulate more and more properties, and the bank is under pressure to sell, well, if you're under pressure to sell, oh, you need to sell a lot of stuff now. Then the buyers can be a little bit more stingy in terms of the offers they give because they know you have to sell. And so the more money you put down, the safer the bank is. So if we are going into a situation like this, if we have to liquidate the house or auction off the house, we may not get the full value. And so this could cause a decrease in assets to be distributed. So we can liquidate and we can auction. These are both possibilities. But it would be nice if there was something else that we could do.
Could you have the husband and wife rank their preferences of these items?
So good. So we could do ranking. And maybe a little bit more than just ranking. Because I don't want to say 1, 2, 3.
Are we allowed to rank children?
I'm sorry?
Are we allowed to rank
You
children?
are allowed to rank children. You don't necessarily want the children to know that they've been ranked. And so when Kim and Kayla were young, people would sometimes ask me which kid is my favorite. And I know this is being recorded. And the answer I would give is whichever one slept better the night before. It was a day-to-day battle.
Amazed put price tag on each item or children.
Yeah. Price up. So just because we don't have all money, we can assign a cost to each. Will those values be the same? No. And so what we can do is the husband and the wife can come up with their own stream. So the husband will assign H1, H2, Hn, and the wife will assign 1, 2, 3n. And again, it doesn't have to be husband-wife. Any two agents work. I want two different letters. So we have our preferences. What happens if they don't add up, if they don't split up nicely? So what could we do if they don't split up nicely?
What you could maybe do is you could have, right, for each item, the person who offers the higher price has to pay the other person the lower price for that.
Okay, so one is that you're doing almost a transaction item by item. That's one possibility.
You could just give them the set number, fake money to allocate across all of their.
Right, so if we have money as a slack variable at the end, if we still have some dollars to distribute, we can say, let's assign the husband these items, let's assign the wife these items, and then make up the difference with cash. Now the question is, how do you determine the worth of what the husband has?
How much she's willing to pay for it.
So what you can do is you could say, if I'm giving the husband items 1 through k, the wife will value that at, say, W1 plus W2 plus WK. And then the wife will know how much she values her remaining bit. And she will know if she's come out or not. Similarly, the husband will know if he's come out positive or negative. And then you can fix things by assigning cash. The question then is, how much cash do you assign? So, what you really want to do is you want to put in specific numbers. So let's say we have 100 units. Right? Take something nice. And we'll say we have maybe 5 items. Somebody give me a 5 vector to how to split up the $100 among the 5 assets for the husband.
20, 20, 20, 20,
20, 20, 20, 20, 20. And now for the wife. And please don't say 20, 20, 20.
30, 30, 30, 0, 0.
Okay. 30,
That's
30,
right, 10, 0.
30,
10, 0.
10, 0. So how would you divide things up? How many ways are there to divide things up?
2 to the 5th.
So there's 2 to the 5th or 32 ways. Okay, can we cut down on the 32 ways at all? Is there anything we can do to cut down from 32 to something smaller?
Well, yeah, because it would be fair to give someone all 5 of them, right?
Okay, so it's probably not going to give somebody all 5. So that might get rid of 1 or 2 possibilities. I think there's another thing we can do that will really help if you just look at these numbers.
Don't give the wife item 5.
Yeah, don't give the wife item 5, right? It seems logical to believe that the husband should get item 5 and the wife should not. As the wife values it at 0. So now, how do you want to divide the remaining assets? I can think of several solutions. Now what's nice is these 3 objects here and these 3 objects here are equivalent. Any thoughts?
I mean, it seems logical to just give everyone the thing they care more about,
Okay.
which would be the wife gets all 3 30s and the husband gets the other 20.
So if you do that,
But
then the husband gets 40 points, the wife gets 60 points. So if you do that, the husband's clearly going to say, I'm screwed.
yeah,
And the wife is going to say, good.
Something really one more sort of thing.
But when you look at this, I think there's another item where it's pretty logical as to which way you might divide it.
10, 20?
Yeah, the 10-20, it seems like you really want to give that to the husband, and the 30s you really want to give to the wife. So I would say, what if we give this 20 to the husband and give the wife none of that? Now we've got 3 items left for the wife and the husband to divide. How would you divide those 3 items?
Just pick any two.
Yeah, pick any 2. So in fact, I'll pick these 2 to start, make it a little bit easier. Not pick that one. So now, and again, I love simple examples. What does the husband think he got?
60%.
And what does he think the wife got? 40. Is the husband happy? Yeah, stuck it to her. What about the other direction? What does the wife think she got?
60.
And what does she think the husband got? 40.
Here's a question though. What if they're actually so vindictive
Okay, well,
that
so-
this is not vindictive enough? That they're mad that the other person thinks they're better off.
So it's an interesting question where it's not enough that, in my mind, that they're worse off. I want them to feel that they were worse off. That might be hard to do. You know, there's only so much you can ask of mathematics. But over here, both people feel like they got the better deal. Yes?
We could do wills by just reversing them all, right? So they're like, they both think I got screwed, but hey, he thinks he got 40%.
So you could do that, and is it worth it? But while you might feel you got screwed, you would actually feel, so this is interesting now, this is psychology. So I would feel that I'm screwed. I know that my spouse feels that they were screwed. I know my spouse actually did better than me according to the way I value the world. And do I care that they did better than me, or am I happy enough that they just feel that they did worse than me? This is getting really, you know. But would you allocate any cash in a situation like this?
Well, here you don't have to. It seems they're even, right?
So you want to be very careful about the procedures you come into place. So if you ask the husband, do you think you owe your spouse anything? What will the husband say? Let's assume it's an amicable divorce. The husband will say, yes, I'm actually getting too much. I should give her a bit back. And if you ask the wife, she should say, yes, I think I'm getting too much. Fortunately, there's a third category where you can just dump the money. It's called the lawyers. If they were involved, you wouldn't have anything close to 60%. But in a situation like this, would either one give money to the other? What if the husband didn't know the wife's preferences? What if the husband just said, I see I'm getting 60%. I think it's reasonable to give some cash.
Maybe they both kind of independently come to the same conclusion, and then they both offer each other the same amount of money.
So that could actually happen. So in a situation like this, what would you want to do when you're negotiating? So we're not covering a tremendous amount of material today. We're covering really just deep thoughts as to how to approach some situations. What would you want to do in a negotiation like this?
Tell each other your preferences.
So we are right now we're sharing preferences.
Lie.
So do you want to share your preferences? If so, do you want to be honest about sharing your preferences? Could you give me a new, let's have the husband be a liar. Give me a new set of preferences for the husband. Husband, wife, lying husband. How much did the husband say he values each thing? One is 50, 50, 0, 0, 0. I think there's some good in that, but I don't think it's...
Maybe 29, 29, and then however that adds up, what would be 26, 26,
So would you want
26?
29, 29, 29?
29, 29, hold on, 14, 14, 14, I think works.
How much should the husband value the fifth item?
It doesn't matter, you just need to get all three of them.
So the husband will get all three of these, depending on what he
The
puts there.
important point is that we've taken away 18 points of value.
Right. So at this point, it looks like the husband is valuating these as 58, and that's going to go to the wife. How much should the husband value? So the husband has 42 points to distribute among the last. How should they distribute?
Something like 30, 11, 1.
I might do 31, just to make sure you actually get item. I'm not sure what the best is, so 31 here. What would you do for the next one?
11?
11.
Uh-oh.
Maybe reduce one of the 29s. to
Yeah,
28.
make one of the 29 to the 28. And
So we can offer one for the last item and get it.
Or maybe you can still win out by doing, 31, 10 and 1. So if you were to do this, it seems clear that you should be getting item 3 because you value item 3 more. And then if they get items 1 and 2, that's already giving them a 60. And even, it seems like you would then get these 3 here. If not, we could play games a little bit. If you want to be safe, do 30.5, 10.5, and 1. And do something like that. And so if you lie like this, you will get the last 3 items. And you will value those last 3 items as 42. And your spouse will believe that you value those items as 42. And the spouse will believe, they'll say, look, I got something worth 60, you're saying it's worth 58, okay, that's noise. We basically both agree that the first 2 items are worth approximately 60%. And I'm taking advantage of you. So I should give you some cash back. I think if you do all the analysis, I think this is the division that's going to come up. That the husband gets the last 3, the wife gets the first 2. And in this case now, the wife would actually give the husband money. So what have we learned from this? Nobody wants to say it publicly? What's the lesson?
Lie.
I would say it could be advantageous to lie. Well, if it's advantageous for the husband to lie, there's also advantages for the wife to lie. And so both people could be lying. And so the question is, when you're designing a system, you want to design a system that hopefully is immune to lies. So we had a nice talk on Gill-Shapley earlier, and in the Gill-Shapley algorithm, if people lie about their preference, it's not going to help them in certain ways.
Depends on who.
Depends on who's lying. But you want a system that is a little bit robust against lying. So what I would like to do instead is, let's imagine we just have a continuous bar, and we assign a value. And so here's 0, here's 1. And if I go to x, the husband assigns a value of f of x to this, and a value of 1 minus f of x. So let's do h of x for husband. And similarly, the wife assigns a value here. Is there a way to fairly divide the bar? So let's assume that h and w are continuous functions. What's the simplest way to divide the bar? Yes?
Well, they're going to intersect at some point. If we assume that the functions are kind of strictly increasing, decreasing as you get more of the bar.
Right.
there will be a point where they value their halves equally. If they're
Not necessarily. What if the husband really values the stuff down here, maybe or down here?
doesn't matter.
Okay,
They're continuous.
they're continuous,
Cross.
so they have to cross. So if you look at this over here, here's 0, here's 1, and so we have a unit square, and we have an increasing function. That's the husband's values. And then we have an increasing function that's the wife's values. They have to intersect somewhere.
Well, but wouldn't it be a decreasing function? 'Cause
Oh, sorry.
We're allocating opposite ends of the bar.
Well, opposite ends, okay, good. So we start over here where the husband is getting 0 and the wife's getting everything good. Thank you. So it's decreasing down like this. So there has to be a point of intersection. So if you look at it, over here the difference is positive, over here the difference is negative. What theorem guarantees us a solution? An immediate value theorem. And depending on the type of continuity of the function we have, we can even find where that intersection is. So there will be a point where both people will feel they got 50%.
Well, both people.
Oh, sorry, both people feel that they got the same. It might be more than 50%.
Less than
It might be less than 50%, that's the problem. What if it's less than 50%? Is there something you could do? So could you swap and go from the other direction, maybe? Will that work?
You'd have to.
Yes, because if they both feel like they got 40%, then that means they think the other person got 60. So
Yes,
split.
so if they just switch, right? Sometimes there's a really simple word story. If we both feel we got 40%, we both got the same, then we must both feel the other part is worth 60%. So if we switch, it makes it better. So what you could do in a situation like this is you could lie. Maybe you value the stuff over here. I like numbers that are less than 0.2, and so I'm going to really value the stuff there highly. But I might pretend not to. Very similar to the games we played over here. So the question is, what could you do to protect yourself from somebody lying about their preferences? Because we just saw that if you lie about your preference, you have a way to take advantage of somebody.
If you know them,
But let's say you don't know them.
why are you getting divorced?
I'm sorry?
And why are you getting divorced?
You're getting divorced because the other person refuses to share their preferences with you. Yeah. And you just want to say, look, I believe our marriage is rock solid, but just in case in the future we have a split, I just want to know how you value things now while we're still speaking to each other civilly. And your spouse goes, and that actually starts the whole terrible catastrophe that leads to the divorce. It's like, how dare you bring up us getting divorced? It was interesting, well, no, I won't say that with this being recorded. So I will leave this as a question for you to think about. So remember to email me if you were here today. But think about what could you do in terms of a very simple way of dividing stuff to take into account the fact that somebody might be cheating and lying about their preferences. There is, I believe, a very simple solution. And it's one of the things I like about this problem. I love things where I don't have to spend 3 blackboards going through intense mathematics. The fact that, well, if we both feel we got 40%, then we both feel the other side is worth 60%. Let's just switch. That's a nice, simple solution. So I think there's a very simple solution to deal with the fact that somebody might be lying and lying in a way you don't know. And there's a way that will protect you. Now again, it can't protect you for any lie. But if you were to do this with lots of different random lies, I think on average you would be fine. You have to really think about what can you be protected against. You can't protect yourself against everything. But on average this should work. Now if somebody's lying, if this person is saying that they really value these at 58, then you could say, okay, fine, I'll give you those too, because maybe I was lying about valuing those at 30. And so you always have the problem that your bluff could be called. I will let you think about that.